All right, welcome to Objective 8 for the broken tag generator. This challenge involves looking at a web application and trying to exploit it to get a environment variable out of the system. And this web application is it's pretty simple. It's basically a document editor that allows you to upload custom images. You can add text and um, place your images, design just this little card that then gets printed out, or you can save it to your desktop. So let's jump right in. So for this challenge, it says we need to find the environment variable greets, or the value that's stored in that environment variable. And we can talk to Holly for help with this. So I have pulled out, just for ease of reading, all the applicable hints. So Holly said the following, or basically I summarized it, but review the source code, look for error message disclosure. So like when a web page shows us like a SQL error or file not found or stuff like that, things that the actual server would be outputting. Enumerate all the endpoints, so all the web endpoints, we should try to discover those and play with them and see what they do. That's a big thing in web application security assessments is sometimes there's undocumented endpoints that or endpoints that you can manipulate to do more than the programmer intended. Content type, hindering browsers. So the content type is how the browser and the server basically agree on what sort of content is being delivered to the browser, and typically the browser will then take that header and treat that as absolute, that whatever type that content type header is storing is what the browser should try to render. So if we're being delivered text content, but the content type is something of an image, it might try to render an image and not actually give us the data we're looking for. Blind command injection. So basically inputting user input and trying to manipulate the server to execute that input as a command. And the blind part is we don't get immediate feedback on it, as if we were typing in a terminal. So it's a lot harder than if we were to get feedback from the server on that. Output redirection. So we'll see what that is in a second. So, and then Noel had said that weird files are being uploaded. So we've got each of these: patience and timing, source code analysis, retrieval. So these are all the hints that you can get if you go through all the characters and stuff. So just going down, remember the processing happens in the background, so you might need to wait a bit after exploiting, but before grabbing the output. So there's actually two ways to solve this challenge. One is a lot easier than the other, and we're going to be doing the easier one, but I'll briefly touch on the more difficult one. So we don't really have to worry about this one. Source code analysis, again, that's more for the harder one if you want to go that route. But we're going to be looking at how we can pull back the source code for the on the server side, so that we can do a source code review and try to see if there's anything to exploit there. Again, yeah, we'll be retrieving the source code. Endpoint exploration, is there an endpoint that will print arbitrary files? Content type, yep, so we have to be careful with that. Redirect to a download. We talked about the error page. And then download file mechanism. Once you know the path to the file, we need a way to download it. Okay. So to launch this, we just click, this is in the wrapping room, we just click this to open up the application. You can see you can select one of these templates, add some text. This is all just like pretty much a JavaScript client-side application. I think this is actually a library that they're using that's open source. So nothing really too fancy here. What we want to do is try to find really what's going on. What is the application trying to do? Upload and download is always important to look at, especially upload, because anytime we're providing a server our input, there's potential for a vulnerability there if it's not handled properly. I'll just cut to the chase. To find the error message path, I just gave it a path that I know doesn't exist, and it tells you here, error in applib app.rb route not found. So this is actually disclosing where on the application server that the source code lives, which we'll see in a minute or so here how useful that will be for us. All right, so I'm going to go ahead and open the developer tools. Let's go ahead and expand this out. All right, I'll do Control R to reload. So the developer tools work similarly and across all the browsers, so it doesn't really matter which one you're using. But here, so what I want to do is let's select a blank template and let's go ahead and upload a file here. Okay, so we can see it appears here. We can also see the request that was made by the JavaScript. And we are doing a get. So after the file's uploaded, we're actually getting it from the server. And so we can see that we make this call to this image endpoint with a URL parameter ID, and then we're specifying, excuse me, the I'm assuming here, we are specifying the ID of, or the name that the server has applied to the file that we uploaded to the server. And so this is actually probably most likely living on the server. So after a lot of playing around with the rest of the functionality of the app, I even went and used dirb or dirbuster to enumerate some endpoints. I wasn't finding a whole lot, so I took a look at this image thing, and I figured if this file is living on the server, perhaps this is vulnerable to file inclusion, whether that's local or remote. And so local is typically easier, meaning if the path for this input is not controlled properly, we can do a little trick to basically escape out of the current directory and go all the way to the root of the server of the file system and start pulling other files. So let's go ahead and try to do that. So we'll go ahead and copy this into another tab, and we can see if we just go to that address, we get the picture that we have in our tag. Now, if we want to try some local file inclusion, we can try and get the source code of the application. So to do that, we will do .. and we're going to do that a bunch of times. And what this is doing in Linux is it's traversing up a directory. So what we're doing is from wherever in the file system that our uploaded image is being stored, we are traversing all the way up to the root. And it doesn't matter if we go beyond / or the root, it'll just cap us at the top of the file system. So we'll do this a bunch of times, not knowing exactly how far up to root it is. And then what we'll do is app, or actually I need to remember what the exact route was here. So let's look at the error message again. So it's applib app.rb. So app/lib/app.rb. Okay, so now you can see that we get whatever that is. And this is this content type mix-up. If we take a look at this request and we look at the headers, the content type is image/JPEG. So the browser is treating that as the source of truth, and is thinking that it should be trying to render a JPEG. And obviously this Ruby script, Ruby file is not a JPEG, so it's not going to render. So what we can do is, if you have Burp Suite, you can use that. We'll just do curl, old-fashioned curl, and we can curl for this file, and we can output it to app.rb. Okay, and now this is actually how you get the source code for the that the application is using to run. So now we get access to all of this, which if you do go about solving this the more difficult way, you can find one of these endpoints that is susceptible to basically taking in user input, and you can craft a special payload and have that extracted to the file server, and then essentially get set up like a reverse shell or something like that. But we're not going to go through all that work. I mean, you can read through the source code. It's kind of interesting. But we're going to take an easier and lower hanging fruit type approach to this challenge. So let's go back to our browser here. So we know that we can arbitrarily access this file on the file system of the server. Now, there's just the way Linux works. If you're unfamiliar, everything on the basically everything is a file. So things related to like device drivers and kernel modules, even though they're technically not a file like they would be on Windows, they're represented as such on Linux. So after doing some research, there's something called procfs, which is the proc file system. It's a virtual file system which is created when the system boots, and it contains information about the processes that are currently running. Okay, so you've got these files that are created on the fly that provide us information about running processes. So after doing some research for, basically we know we have to get the environment variables or a specific environment variable. So I did some research on, does Linux store these in any file? And this is where you start reading about proc and proc/self. So there's this answer on Stack Overflow that gives a pretty good description of it, but being that proc/self is not really a folder, it's a device driver or a kernel module. Again, that's being generated as the system boots as a virtual file system. Okay, so it generates its contents dynamically by reading data from that process. So you can actually replace self with any process ID, and it will give information for that process. Self is actually it gives information for the calling process. So whatever called this, whatever process called this, it'll give information for just that process. So anyway, that being said, there is a sub file, I guess, or sub information for proc or procfs called environ, or ENVIRON, I believe, and that actually shows the environment variables for the given process. So because of the way Linux works, we can actually request that file, proc self environ, and it is going to contain the environment variables that the running process has access to. And if you think about it, that's really all this task is asking for. It's not asking for us to get, a fully functional, responsive, reverse shell or full, command execution. It's simply asking for the greets environment variable. So let's go ahead and finish off this challenge by pulling that file back and looking at the contents of it to see if it has this information. So we can go back and use curl again. We're going to use the same local file inclusion, and we're just going to do proc self environ. So it's going to tell us, this binary output can mess up your terminal. We don't care, so we'll append -- output space dash to tell curl to output the binary anyway. Okay, and we get all these environment variables. We see some Ruby stuff in here, which makes sense. And then at the very end, we see greets. And then this is the answer. Jack Frost was here. Okay, so we can take this and plug it in just to see if we're right. And we are. Okay, that's how you solve that challenge. Like I said, there is another way of doing it if you look at the source code, and you can develop a payload to get some sort of command execution on the system. Because there's a ton of other write-ups already out there that describe that process in detail. I'll leave that if you want to research other write-ups for how to do that. But in the interest of keeping this video somewhat short, we'll stop there. So let me know if you have any questions on the way I did it, and if not, we'll see you in the next video.